In this part of the course, we will learn various machine learning models, which are commonly used for prediction, classification, clustering, etc. As I already mentioned, machine learning is broadly classified into supervised and unsupervised learnings. Supervised learning means that the algorithms are supervised during the training phase. So, in other words, in order to train these algorithms, we need data that have labeled targets. For example, if a model is being created for predicting house prices, then the historical data that is used to train the model should have a target column stating the price of a house. Unsupervised learning is when we don't have a target labeled data. In this case, the algorithm classifies objects based on some existing features. Supervised machine learning problems have two categories of learning: regression and classification. Regression algorithms are used to identify a relationship between a dependent variable, target, and independent variables, predictors/features. So in regression, the target is always a continuous variable, and the predictors can be continuous or discrete in nature. Regression is best used for finding causal effect relationships between the variables, forecasting, time series modeling, etc. In regression analysis, the model tries to fit a curve to the data points in such a manner that the difference between the data point and the curve is at a minimum. On the other side, we have classification models. The classification models are used to predict the target that has discrete values. For example, class of fruits, orange, pineapple, and lime, or predicting whether a patient is suffering from cancer or not. For this kind of use, machine learning models collect insights from the historical labeled data and use these insights to predict the target class. Okay, listen up, don't forget this. Regression and classifications are all supervised learning models because we have a labeled output, which we need to predict. If this labeled output is continuous, we use regression, and if it's categorical, we use classification. Now, the most used unsupervised learning models are clustering and association analysis. Clustering is the most important unsupervised learning model. It deals with finding a structure in a collection of unlabeled data. So a loose definition of clustering could be the process of organizing objects into groups whose members are similar in some way. I will present clustering in more detail later. Association analysis models discover relationships in large data sets. Hidden data relationships will be expressed as a collection of association rules and frequent item sets with association analysis. Association analysis isn't frequently used. We will not focus on them in this course. What are the machine learning models associated with each of these learning types? I mean, which models are dedicated to regression, classification, and clustering? For the regression purpose, we commonly use linear regression, decision trees for regression, support vector machines for regression, SVR, or neural networks. For the classification purpose, we use logistic regression, decision trees for classification, support vector machines classifier, SVC, nearest neighbor, or neural networks. In unsupervised learning, we use the k-mean clustering. If you enjoyed this video, please like it, share it, subscribe to our channel, AI Sciences, and make sure you click on the notification button so you can receive a notification when our next course is ready. See you at the next video.